Okay, so in this class, we're going to do this numerical test 9.1a, okay? So these are the examples that we're going to do, and right after this, you'll have a test. So let us start with example 9.1, which you'll find on textbook 1, page 128. So open your textbook to page 128. Before we start, this is the main formula we're going to use in this chapter, which is force is equal to mass into acceleration. And so keep this one in your mind, okay? This is the main formula we're going to use. So this one, force and laws of motion, is the chapter. Let me read the question. A constant force acts on an object of mass on 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 to 7 meters per second. Now find the magnitude of the applied force first. Next, if this force was applied for a duration of 5 seconds instead of 2 seconds, so there are two cases here. So case 1, let us write down. Case 1. Here, in the case 1, we can write, as we read the first and second sentence, clearly M means mass, and 5 kg, unit of mass is kg, so we know this is mass. Duration means time, so T is 2 seconds. Let us go slow. Now, when we do this, your constant force is applied, so F is applied, which we don't know. And so on a mass, T1, let us say this is T1. Then the velocity increases from 3 to 7. So first one that appears is the initial velocity, 3 meters per second. And it was, as you apply this force F, it increased to 7. So that is called the final velocity V, initial is U. With this, you have to first find out this force applied. So let us write down. Since our primary formula here, F is mass into acceleration, you can write that, okay? Now in our chapter 1, we learned that V is equal to U plus AT. So this AT, if you keep on one side, then it will become U go to the side minus U. So A will be V minus U divided by T will come down. So this is A. So this A can be replaced by M into V minus U divided by T in place of this A, right? So now once we do that, we can replace the values. V is here. Okay, M, let us write down first. 5 kg into V here, 7 minus here, 3, and both are same unit, meter per second. So I can just bring out of the common, of the bracket as common factor. Instead of writing twice, you can do that, okay? So maybe you can just go the same way as we did in the previous step. Divided by T here, T1 we're using, so right there T1, 2 seconds. So this is what we're getting. It's a matter of doing carefully. Now you see here, once we're through with that, you can write here 5 kg into 7 minus 3 is 4 meter per second divided by, or you can just continue in the same fashion as the previous step, divided by 2 seconds. So here 2 ones are 2, 2 twos are 4. You can do that. Then here 5 twos are the numbers only, 10. Here kg, meter per second up to here. This one, if you bring up, then it will become second to the power plus 1. No number means plus 1 is there. Become minus 1. Right, so here we get a force of 10 kg meter per second. Minus 1 is minus 2, so meter per second square. And we learned in our chapter that this is the base unit of force, kg meter per second. And in honor of the scientist Newton, we can just simply put as Newton. This is the main unit, but the basic, it comes from the base unit, kg meter second, written in short in honor of the scientist called Newton. So kg meter per second square can be written as Newton. So this is the force. So let's just write here 1. And let us go to case 2. Case 2 is find the magnitude of the force. Now if this force question is saying, so let's just write down, if this force, that is this F equal to 10 Newton, that's what it's saying, we found out just now, okay, was applied for a duration, okay, a duration of 5 seconds, comma, what would be the final of T, let us put it here itself, T, okay, Tn, let us put Tn equal to 5 seconds. Then what would be the final velocity? Let us denote by Vn. So this is what they're asking. So let us do, as we go on here, again the same force is applied, so we can just write the same formula and the same mass, right, and acceleration is same, so m is into this, a can be replaced by Vn minus u divided by Tn. That's all, taking the time, new time. Now next is the same object, so same mass, right, 5 kg into here Vn, we don't know, okay, let's just shift once before we do this. So if you shift this, Tn into F will become F into Tn is equal to m, this and this you shift, this down, up will come down and down will go up, so this is left with only Vn minus u. They're asking you to find Vn, so let us substitute that. So we get here Vn, you leave it behind, then here F into Tn by m, and minus u come this side. So this is the formula for finding this Vn. So we can write here if you want Vn, just bring it this side if you want, or like that also it's okay. F here, we have to use this same force applied, they say, so 10 Newton into Tn is the 5 seconds, the new time you have to put, divided by the mass is the same, 5 kg, same object, so same mass m. U is going to be the same as the previous case, which is 3 meters per second. Only thing they're asking is final velocity, what will it be if the duration is changed. So the initial velocity will be same, u as the previous, you are taking u value of the previous case, okay. Now it's just a matter of solving carefully, 5 and 5 cancel. Now listen carefully here. Now we know that kg meter per second square is the best unit of force, which can be written in Newton, short, in honor of the scientist. So reverse is also true, n can be changed to this. So let us change this 10 Newton to kg meter per second square. So n is now reversely changed to this base unit, divided by, here kg is left, so just keep it, plus 3 meter per second. Everything is in base unit, so it's okay. That way you can cancel these two. Right, so here, meter per second. Okay, so Vn will be into Tn, 5 seconds. So 1 second is left here, sorry, kg meter per second into, see here, please observe this one carefully once. This portion, 10 Newton can be replaced by kg meter per second square, and there's a second here, we've missed it. So next step, we can write it down, that will be equal to, here see, 10 kg meter, then this second square, if you bring it down, it becomes second to the power plus 2, minus 2 power become plus 2, then into second. So this second to the power 1 and 2 minus 1 is still 1 left. So plus here 3 meter per second. Right, that's quite easy, right? So here 10 kg is gone, sorry, kg is cancel TSC. Kg cancel with this one, sorry. So this is 10, let's write once more. So here 10, then here meter per second square brought down, then plus 2, minus 2 become plus 2. This one in the same place, so just keep it, and this gone, and 1 power is cancelling this 2, so 2 minus 1, 1 still left. So we're left with meter, and if you bring this one up, second to the power plus 1 will become second to the power minus 1, plus 3 meter per second. So your answer for this will come out as equal to 10 plus 3 is 13, same unity, meter per second, meter per second. So this is the velocity if you change the duration of the time from 2 seconds to 5 seconds, if you are accelerating for 5 seconds. So your final answer can be written here. Therefore, question is saying find the magnitude for, therefore, magnitude of force applied, which is F, is equal to 10 Newton, as you get this one by using equation number 1, and we may as well put this one as 2 then. And case 2, and in case 2 you can write down final velocity Vn is equal to 13 meter per second, as you get this one by using equation 2. Okay, so that's the first answer. Let's go to 9.2 now. So example 9.2. This is on textbook page 129, I think. Okay, so these are all simple questions, but need a little bit of patience and careful observation. Let me read the question for us. Which would require greater force? Accelerating 2 kg at 5 meter per second square, or 4 kg mass at 2 meter per second square. So here there are two cases. So case 1, let us say, accelerating at 2 kg mass at 5 meter per second square. So this is the acceleration. So here in case 1, greater force, so F1, let us say, is the question mark, the force that you're going to require. So acceleration here, the unit of acceleration is meter per second square from the first chapter 8 we found out. So this is acceleration. So we write here, this is mass. Very clearly from the unit itself we can know that those, what is the physical quantity? The answer is in the unit, right? Then acceleration, here let us put M1, A1. So M1 is 2 kg, A1 is this one. We know that meter per second square is the unit of acceleration, so we know this is A1 acceleration. Now we write here, since by formula, by second law, we have found out that force is equal to m into a, mass into acceleration. So mass is 2 kg, m1 into a1, and a1, don't forget that, into a1 is 5 meter per second square. So this is 2 5s are 10 kg, then here meter per second square. So this is the base unit of force, kg meter per second square, which we know, I've been repeating, written in short as Newton N, in honor of the scientist Newton. Okay, so here, this is the first one, F1. Then case 2. In the case 2, accelerating a mass of, go to text, 2 kg mass at 5, or 4 kg mass of 4 kg at 2 meter per second square. So in case 2, there will be a different force applied. So F2 is question mark. Mass is also different now, 4 kg, M2, and A2 acceleration It's also different value, 2 meter per second square, different from the first accelerating. Question is saying accelerating this 2 kg mass like this or 4 kg mass like this will need greater force. So we're calculating to find out. So continuing with this one, since basic formula is F equal to ma, m is now 4 kg, acceleration is 2 meter per second square, so 4 2s are 8 kg meter per second square, which is written in short as Newton, equation number 2. Now since F1 is greater than F2, since F1 is greater than F2, since using equations 1 and 2 we can clearly find out, and here see F1 is 10, so the first case is going to need greater force, so we will write here first case is accelerating 2 kg, therefore write the answer, you can write it here maybe, therefore accelerating 2 kg mass at 5 meter per second square, 5 meter per second square would require greater force than accelerating 4 kg mass at 2 meter per second square. So first case is going to need greater force. That's your answer. Let's go to 9.3 then. Let me read the question for us. Motor car is moving with a velocity of 108. Okay, so let's just write down example 9.3. Since the motor car, you can write like this also, motor car is moving with a velocity of 108 kilometer per hour, and it takes 4 seconds to stop after the brakes are applied. So from this statement, first sentence of the question, what can you get out? Can you bring out the physical quantities? With a velocity means first appearing is initial velocity 108 kilometer per hour, means you can write like this also, brought to the numerator. Now we know the SI unit of velocity is meter per second, so we need to change this by using kilometer, hectometer, meter, kilometer, hectometer, kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. Then we have for time, hour, minute, and second. So here we have to change to meter, kilometer to meter. So 1, 2, 3. One place is 10, 10, 10. So 310 is 1000. So since you're changing big to small, multiply 108 to 30 means like this at the back, and kilometer will go away, meter will come in. Then in the denominator, nothing is there, means 1 hour is there. So if you want to change to second, 1 place is 60. So double will be 2 times 60 into 60, then hour will change to. So this is how we change, right? We've done this enough number of times even in the first chapter. So 0 and 0 cancelled. I think 6 is going, so 6 ones are 6, 4 in hand, 6 8s are 48, double 0. Then 6, sorry, 1 0, not double 0. 1 2 0 cancel means this also cancelled. And here 2 ones are 6, 6 8s are, so only 1 0. 3s are 18, 0. So in SI unit is 30 meter per second. We have to use SI unit. Then it takes 4 seconds, means 4 seconds tells us that it's time, so we just write t is equal to 4 seconds. To stop means finally stop means final velocity is 0 meter per second. And there, second sentence, calculate the force exerted by brakes on a motor car if its mass is along the passenger is 1000 kg. So, and its mass together with all the passengers, including the masses of the passengers, is 1000 kg. Therefore, the mass here involved is 1000 kg. So let us say this is the case. Now you can do like this also. So here you can write down, therefore F, we have to find out, find the force exerted. So here we write down F equal to question mark, the force exerted. So basic formula for that is since F equal to M into A. So we can write M into V minus U divided by T. We know A is V minus U by T. So because these values are involved. So this is 1000 kg, as you can see here, mass. V is here, you can see 0. So you can just put there 0 minus U is 30 meter per second, you can bring out as common, divided by time second period after applying brakes. To stop to 4 seconds means time period is 4 seconds. So we can do like that, and then you can just do 4 2s are 8, 9, 10, 2 in hand, 5s are 20, 0. Then here 0 can be just neglected, so 250 kg into minus 30 meter per second divided by, here 1 second is there. If you want, you can bring that one up here itself. So that will become second to the power minus 1. So it's just a matter of multiplying, plus into minus, minus. 3 5s are 15, 1 in hand, 3 2s are 6, plus 1 7, 1 2 0. Here kg, meter per second to the power minus 1, and minus 1 means minus 2. So that is minus 7500. This is best unit can be written in short as Newton, which is negative. This is important, okay? Why is it negative? We're going to explain. Which is negative. Therefore, force exerted. So force exerted by the brake, that means force exerted to stop the car, is 7500 Newton, comma. In the minus means in the force applied by the brake is in the direction opposite to the motion of the car. If it's positive, then the force is also acting in the same direction of the moving object. But if force is negative, that means that force is acting opposite to the direction of the car, like applying brakes is always opposite to the direction of car. That's why it stops, right? So that's your answer. Now here, you don't need to write minus if you don't want. If you write also, it's okay. Here you have to write minus. If you have, since you have mentioned opposite to the motion of the car, therefore you don't need to write, okay? So this is 9.3. One more question, and then we will go and give the test. Example 9.4. So there, look there. A force of 5 Newton gives a mass m1, an acceleration 10 meter per second square, and a mass m2, an acceleration. Which acceleration? Okay, so case 1. Since a force of 5 Newton gives a mass m1 and acceleration of 10 meter per second square. And okay, so this much. With this, let us calculate what acceleration would it give if both the masses were tied together. So here F is 5 Newton very clearly. M1 mass we don't know. A1, okay, A1 is 10 meter per second square. So with this, let us find out M1. Since we know by formula F equal to M1 into A1, therefore you want to find M1, then don't move M1, don't move F. This A1 shifted left side, then will come down. So A1 5 Newton, F, as you can see, A1 10 meter per second square. So let us just divide. Before we divide this, maybe we can do 5 Newton base unit can be changed to kg meter per second square. The base unit of force, as I said, is kg meter per second square, which is written in short as Newton. But this also, Newton also can be changed to the base unit. So we did that. Why? So that we can cancel out the denominator. That's why we're doing meter per second square. So this cancel, this cancel, this cancel, this cancel. So you're getting M1 equal to 5 by 10 kg, which is equal to, you can write down here 0.5, because 1 0, so decimal here will move to the left of 5, and 0.5 kg. Let us put this one as equation 1. Case 2, let's look there now. 9.4, okay. So and a mass m2 and acceleration of 20 meter per second square. So this here m2, so the force is the same force 5 Newton is applied on a different mass m2, which we don't know yet, and it gives that mass m2 unknown mass a2, let us say 20 meter per second square. So here similarly, like we did in the first case, you can just write down m2 here will be equal to f by a2, just like we did, shortening the steps. That's why we're writing similarly here. So that will give you 5 Newton divided by a2 is 20 meter per second square, right? Now here 5 4s are 20, so 1 is divided by 4 is simple case of 0 point, and 10 4 2s are 8, 2 in hand, point means I can put 0 here, 0.25, okay, and Newton can be written as kg meter per second square. As we have been saying, Newton can be changed back to base unit, and down here is meter per second square. So these two cancel, this meter cancel. So 0.25 kg is what you get as m2, and m1 is this one. So finally, these two are tied together. So case 3, let us put finally what acceleration. Okay, let's just write down the last statement of the question. What acceleration, let us say a3, would be, last sentence, would it give, we can write like this to keep it simple, if both the masses were tied together. So this is the question. A3 you have to find out. So let us do that. Now let us write here, let M be the total mass then, when the two objects are tied together, m1 m2. So common sense, m will therefore be m1 plus m2. m1 is 0.5 kg plus m2 is 0.25 kg. You can write your since using the equations 1 and 2, right? Getting right? Okay, that's good. And once we're through, we add this, then you're going to get 0.75 kg m. What acceleration would it give if both of these are tied together? Okay, so if they're tied together, F is still same. That means the same force applied is still 5 Newton. If the same force is applied to the two mass together, what acceleration? That's what they are saying. So since by basic formula F equal to m into A3, because we are taking here acceleration A3, therefore A3 will be F by m. With this you're going to calculate the final step. So let's do that. It will be equal to 5 Newton divided by, because F is the same force 5 Newton, divided by m, and total mass is here 0.75 kg. So let us write this, change this Newton back to the base unit. Newton in base unit is kg, meter per second square. We're doing this so that we can cancel this kg in the denominator. Kg. So these two cancels. Now it's difficult to deal with decimal in the denominator. So let us just write down. To remove decimal, there are two places. So you have to multiply by 2 0 up and down. Okay. So this into this is 500 by this 2 0 will shift this decimal to the right side of 75 and become no decimal. And here is meter per second square. So 5 1s are 5, 5 5s are 25. Same number, 5 1s are 5, 0 0, 5 3s are 15, 5 2s are 10, 0. So 20 by 3, which is around approximately 20 by 3 is, you can write like this, 3 6 are 18, 2 in hand 0.0, 3 6 are 18, 2 in hand 0, 3 6 are 18. And textbook is going up to second place by going to third place. So let us go to third place. Then you're going to get 6.666 meter per second square. As you can see here, acceleration unit is correct, meter per second square. So here 6 point, and then third place of decimal is 5 or more than 5, then the second place will increase by 1. So 6 plus 1. So the acceleration is this much. If the two are tied together and you apply the same force 5 Newton, you will get this much acceleration. Positive acceleration means in the direction of motion. Okay, so this is positive acceleration means the velocity is increasing. Negative acceleration is velocity is decreasing. Okay, so this is the answer. So that concludes this test portion. You can go and give the test. Okay, so do it carefully. Every question is identical on the question paper. Just have to do with a little bit of patience and it'll be fine. Okay.